my own, almost glad to be alone.
Okay, let's get this going. All right, welcome back to CS196. Today we are going to be doing our second part of the Git lecture series that we have, and also the final part. This will be the last lecture on Git. We're going to be covering a lot of very important material today. This will likely be one of the most important lectures of the semester because the concepts that we're going to be covering today are concepts that you will be using in the projects a lot, and it'll be concepts that you'll be using for pretty much the rest of your career, especially if you go into a field like software engineering. So, what are our objectives for today? So, first things first, we're going to be covering what merge conflicts are. Then we'll be going on to this concept called branching, pull requests, resetting, and reverting. And all throughout, we're going to be going through some extra useful commands that will likely be useful as you go through using Git on your own time. Just a quick reminder, drop your questions in the lecture questions chat on Discord. I will be checking that chat first because the Twitch chat can get a little crazy. If you ask questions in the Twitch chat, I'll try my best to get to them, but put them in the Discord chat first. That will be the question. That will be the chat that I look at before anything else. So let's go ahead and start off with a little bit of a review of the big idea from last lecture. So someone please ban that guy in chat because he's being obnoxious. But let's start off by talking about the big idea from last lecture. So we talked about how Git is a distributed version control system. So what does that mean? We talked about how there's 4 different environments. We have the working directory, the staging area, the local repository, and the remote repository. My camera is blocking off the one on the right, but by now you should know what it is. And so we talked about how the big idea is that in order to move between environments, we need to run these Git operations. We need to do git add to go from working to staging. We need to go from staging to local by doing commit. And to go from local to the remote, we have to do git push. This was the big idea from last lecture. And so finally, the last thing that we talked about was the use of git pull. And so the pull command is how we go from the remote to local. If there's changes on the remote, then in order to pull them into our local repository, when we want to get those changes, we run git pull. So that was the big idea from last lecture. Now I want to actually go further and continue talking about git pull. So in the example that I gave you guys last semester, it was basically along the lines of this. We had a shopping list and we had some items on the shopping list. So on the local repository and on the remote repository, we had items that agreed, right? We had some watermelon, onions, clipboard, and a marker. These were the copies and the versions of the file that we had on both environments. And so we said, okay, let's say one member on my team that's working on this project, let's say Rohan, let's say he clones the remote repository, he makes his own changes, he adds his own items, and he adds, he commits, and he pushes so it's visible on the remote. So let's say he adds a laptop. And so let's say now that we have changes on the remote, I want to pull them in to my own local repository because I want to keep my local repository updated. So by now we know what we have to do is to run the git pull command. But one thing that I want to touch on right now is that, this was seemingly perfect, right? We pulled in the changes without any problems. However, when we're working on large-scale projects, especially in a team setting, in an industry setting, not everything is perfect like this. We won't always be able to perfectly pull things in. And the reason to why that is because we have to kind of first look at what Git had to do when we ran git pull to actually bring those changes in. So what git pull does is it'll basically say, okay, well, so on the right side you have all of this, and on the left side you have quite literally the exact same thing, except the only difference is you have this laptop appended at the end. So Git is pretty smart about this. If we want to run git pull, it'll basically say, so you just have laptop appended at the end, and so it pulls it in and just appends it at the end. Git is pretty smart about this. If you have some changes at the top of a file, at the bottom of a file, or anywhere in between, Git will automatically merge them together because it is pretty smart. But now let's say Rohan does the same exact thing. He wants to continue adding some items to the list, and let's say on my local repository, I also want to add some items to the list. So let's say right here, where the marker is, let's say I decide I don't actually want a marker anymore. Let's say I want to have a pen instead, for example. So in my local repository, I change marker to a pen. And so on the remote repository, let's say Rohan also pushes a change where he says, actually, I also don't want a marker, but I actually want a pencil. And while he does that, he says he wants a charger as well. So what will happen if we run git pull here? Because if you notice, up here, we now have some differences. Git will be able to smartly say, okay, I'll add charger to the end, but what do I do about the pen and the pencil? They're on the same exact line. So what happens now? So when we run git pull, we get this terrifying little cryptic thing right here. So as I said, Git was smart. It knew, well, they're basically the same except we have charger at the end, so it just threw that at the end here. However, what will it do about the pen and the pencil? It'll basically say that these changes conflict. Right here, we say that these two changes are in the same exact area, they're on the same exact line, so when we're merging things together, these two things conflict. So it'll basically add this right here. And so at a surface level, this looks terrifying. If you don't know what a merge conflict is, if you look at this in your code, you'll think you did something wrong. And this is a big part to why people are terrified of merge conflicts. However, this is completely normal. What Git is basically saying here is, I don't know as the computer what you want to do with the pen and the pencil. So as a human, you need to decide which one I need to choose, which one I want to keep, right? So the way you can read this is on the top, this is your changes. This is what I had on my local repository. However, on the bottom here, these are the changes that are conflicting. So this extra stuff right here, head is where you currently are in the repository. We'll talk about this a little bit more. And at the bottom here, this little code is the code of the commit that is conflicting. So the commit that we had on the remote that is giving us problems, this is the ID of that commit. So how do we resolve a merge conflict? How do we tell Git which one we want to choose? Do we want the pen or the pencil? Well, it's quite simple. All we have to do is just basically take out the stuff that Git added to your code. So we can just take out the greater than and less than symbols, the equal symbols, all of this stuff. And so let's say I just want the pen, I can just delete the pencil, and we have resolved the merge conflict. So someone asks in chat, is there a way to get both? Yes, you can keep both if you'd like. Basically, all you need to do is at this point, just save this instead of deleting it. All you have to do is just remove what Git added to your code, keep whichever one you want, and then you've resolved the conflict. So in this case, we kept the pen, we deleted everything else out. And so once we've resolved the conflict, we'll go ahead, add, commit, and push, and update the remote. So does anyone have any questions about this? I see that there are some questions already, but some of them I will be answering already in the future. I hope this makes sense. So basically, a merge conflict happens when there is a merge operation and there are conflicting changes in similar areas. And so in this case, this is a question, we will be answering a question about git push, but so in this case, we had a problem with git pull because as we said, git pull, the way that it works is that it has a merge operation under the hood. Behind the scenes, Git is basically comparing your code and merging things together. So there is a merge operation happening. And then there was also conflicting changes because we had a change on the same exact line, pen and pencil. So I'll go ahead and show you guys a live demo right now. So let me go ahead and open up this shopping list.txt. Before, I've been using Vim as my text editor. I'm going to be starting to use Visual Studio Code. This is just my preferred text editor. You guys don't have to use what I use, and you also don't have to always use Vim. You can use, whatever you prefer. So in this case, I'll be using VS Code. And so here is my shopping list on my local repository. And so let's say we have the same exact shopping list on our remote repository. Here it is. And so let's say I do the exact thing that we had on the slides. I change my marker to a pen locally, and let's say I commit with saying added pen to the shopping list. And actually I don't want to push it because I want to show you guys how the changes can conflict. And so on the remote repository, here we have the shopping list.txt. And let's say, again, we're just doing this to simulate Rohan, for example, one of my teammates, working on this repository, cloning it, adding his changes, committing, and pushing. So the changes that we said he would make are replacing marker with pencil and adding charger all the way at the end. So I'll go ahead and commit these changes. And so now on the remote, we have this shopping list. And then on the local, we have this shopping list. And I'll actually just go ahead and move that over. So what happens when I run git pull? So I'll go ahead and show you. When I run git pull, it'll basically give us this slightly terrifying message right here that basically says, I'm Git, I wasn't able to automatically merge everything that you had in these files, so I'm going to need you as the human to fix the conflicts and commit the result. So here we are in VS Code. Now, VS Code is quite nice. It'll give us a little bit of syntax color highlighting, which will basically say, you know, the one on the top is green, this is your current change, and then the one on the bottom is the incoming change, the conflicting change. But this isn't important. This isn't the important part. In fact, I could open this up with Vim, and you'd see literally the exact same thing except without the syntax color highlighting. So here is our conflict. This is what Git added to our code to basically say, I need you to make a decision. So I'm going to resolve this conflict in our text editor here. So how did we say we resolve the conflict? You literally just take what Git added to your code out, and you pick the change that you want. So in this case, I wanted pen, so I'll just go ahead and take that out. I'll save, and then I'll just commit and send it back. I'll just say resolved merge conflict. Okay, and then git push. So someone's asking, is code an alias or an actual command? So just like how you open something up in Vim by saying Vim, you open something up with VS Code by saying code and then the file name, as long as you have it installed. But so the important thing here is we've resolved the merge conflict, and if I go back to the remote, you'll see that we have the pen here now. So does anyone have any questions about this? We will have a Kahoot question. And so someone asked a question basically saying, will you have push conflicts as well? So this is important. No, you will not have problems with git push because there is no merge operation happening. Git pull has that merge operation under the hood, as we said, but git pull, if you have different changes that you send to the remote, I mean, that's completely normal, right? That's like a very common thing that you do when you push to the remote. When you push to the remote, it doesn't merge the changes together. It just basically creates a new commit on the remote with and overriding all of the previous changes. And so that will actually be something that we talk about in the Kahoot. So go ahead and join in with your net ID. And go ahead and lower the volume a little bit. Give you guys a couple minutes. And so someone says, so solving merge conflicts is as easy as deleting the other thing from the file? Yes, it is quite literally that easy. There's nothing special about using the terminal. You just have to, I mean, if you use a text editor in the terminal, that's basically the only thing that you could use the terminal for. Other than that, you just remove what it added to your code and pick the one that you want. And then commit and push. What's in the water bottle? Water. It's crazy, right? Okay. I'm going to give it about like 40 more seconds or so. Get the last few people in. Join with your net ID. You're not funny, guys, with this kind of stuff. It's not middle school anymore. It's college. But I'm sure everyone found it funny. Okay, we're gonna go ahead and get started here. So we'll have a couple questions. So we want to pull, but we have some change in the same place. What does get do? Looks like my camera is not covering anything, so that's good. If it is, I will remove it. No extra credit for this. It's only a few questions. But we will, like I said, have some extra credit opportunities soon. We will be posting that into the Piazza. Someone says, is it recommended that we do get pull before get push just to make sure we don't delete others' work? In general, it is recommended that before you start working, you do run get pull. It's just good practice because basically, you know, you want to keep your local as updated as possible. You don't want to be behind a bunch. And someone says dash A just means all the changes get committed, right? Dash A is basically adding, and it allows you to commit, add while you commit on the same exact line. So it just doesn't add new files, but if there are existing files that you have made modifications to, dash A will add those changes to the staging area, and it's a nice little shortcut to do adding, committing in the same exact line. So well done to the 101 of you. Get is smart, but it's not that smart. You have to choose what you keep. So if you have changes on the same exact line, you need to choose, otherwise it will automatically merge it for you. It definitely will not reject the pull, and it won't always merge it for you. Sometimes you, as the human, need to pick what you want, because it doesn't always know. So one more question. True or false? I want to push, but I have some change in the same place. Will I receive a merge conflict? True being yes, false being no. So people are asking me, is there a reason why we don't use the graphical user interface in this class? And is there a reason why we do everything through the terminal for Git? Yes, I do think that this is something that we talked about in Discord earlier. I think that everyone should be comfortable with the command line. Let me go ahead and turn this down a bit. Okay. I think everyone should be comfortable with the command line, like very intimately comfortable, because one, you won't always be able to use the graphical user interface. In some cases, especially if you're like SSHing into a server, sometimes you will have to do things through the terminal usually. And also, I think that GUIs usually kind of abstract away a little bit too much to where you'll be a bit confused at what's actually going on under the hood. Some people use GUIs, and that's fine. I'm not going to shame them. However, we will only let you use a GUI if you are comfortable with the CLI and you are well, informed on what's going on there. We don't want people using GUIs just because they're afraid of using the terminal or because they don't want to learn. So I think that being comfortable with the terminal is something that will help you a lot. It'll help you understand the concepts a lot more. So that is why we are using it in this course. So this question was slightly tricky. I want to push, not pull. So we said what will happen when we have a merge operation and conflicting changes, we will receive a merge conflict. That is what we talked about in the slides. However, get push does not have any merge operation happening. If there are changes in similar areas and you push them to the remote, there's no merge operation happening. It's just basically, technically overwriting the changes, and it adds a new commit. Pull, on the other hand, when you bring changes in, it'll compare what you have with the new changes, and it'll merge them together. So a little bit tricky, but not the same exact thing. So let's continue. So we had our Kahoot question. So next we're going to be talking about branching in Git. This is a very important concept. This is going to be how you guys develop in your projects, so pay attention. So branches in Git are what isolates the work in progress from completed work in the master branch. So here we are. This is basically how we've been developing in these lectures up until this point. Every single time we made a commit, we basically pushed them to what is called the master branch. This is not really how things are done in especially large team projects in an industry setting. This is not really how it's done. So here's what we've been doing so far. Let's say we have a project where we're working on like an Android app, for example. And so the first commit is where we're starting to build our app. And so we go on, we make some changes, we commit, let's say we're adding a login page. Later on, let's say we add a friends page and another commit. This isn't really how we do things in industry. So branches are actually allowing us to separate work in progress from completed work. And so a good way to kind of put this into picture, it's a little story. So like back when I didn't really know what version control was, or even when I knew what version control was, but I wasn't really that comfortable with it, I wanted to have a way of basically, being able to add changes to something that was already working without having to worry about breaking anything and always having something that is working, right? So if I ever wanted to add a new feature, I would just basically copy my code into a different file. I would have my working file, ready if I ever needed to go back to it. And when I was done making my new feature, I would say, okay, this is working now. Basically being able to separate my work in progress from my completed. But, if you actually know how to use version control, this is already solved. This problem is something that is already solved. So let's say in this case, we're finally using proper habits, proper practice, and I want to add a new feature to our application. Let's say I want to add a settings page. So instead of committing to the same exact place on the master branch, I would actually branch off. I would create a new branch, and what this would do is it'll copy essentially the commit that we branched off from. So in this case, we will have the version of the code that had a friends page, and here we can work comfortably. We'll have like essentially our own playground for ourselves. We won't have to worry about, pushing malicious code into the master branch because we have our own branch for the feature that we're working on. And so the nice thing about this is I can make commits to this branch. So I can, let's say, keep on working on this new feature, and we can work in parallel, which is even more useful in a team environment. So let's say, someone made a change to the master branch. They make some more changes. Let's not worry about what they are. Then eventually the whole goal, the whole point of branching off is usually to merge them back into the master branch, to merge the new feature that we were working on in our little playground in another branch back into the master branch, because the master branch is where we want things to be clean. We want, no malicious code in the master branch. We want people to be able to have a version of the code that we know is working there. So we branch off to make sure we don't have malicious code in the master branch. And so once we know the code is working, once we know that everything is good, we can merge it back in. And so I'm blocking the slides a bit here, but here, when we merge everything together, we will have a version of the app with the login, the friends page, and the settings page. So, that's the idea of branching. These are the goals of branching. So here is a nice little visual of what's going on here. We'll have our feature branch, which is where our work in progress is going. And on the bottom, we have our master branch. This is where the completed work is. The version of our code that we know works, it's completed. We don't have to worry about, people pulling in changes and breaking their code. They know that the code in the master branch should be fine. And so we also have this thing called the head pointer. So this is important because you'll see it, here and there when you're working with Git. I think you saw it in previous slides already. The head pointer points to the commit that you're currently working on. So if we're working on the master branch on this commit, the head pointer will point there. And if we're on the feature branch working on this commit, the head pointer will point there. So A frequent question that we get is, will I get conflicts when I merge the branch back into master? The answer to this is yes, if there are conflicting changes in similar areas in the code. Why? Because we have a merge operation, we're merging two branches together, and if we have conflicting changes, yes, you will have a merge conflict. Otherwise, you won't. And the way that you resolve these conflicts is the same exact way as we covered when we had a merge conflict while pulling. It's the same exact idea, just pick whichever one you want. So now we have a Kahoot question. So before you make radical changes to your team's project that will impact the rest of your team, where should you put your changes? This should be very easy. Someone says, is there a specific command to push to a new branch? We will be going over the commands specific to branching in just a second after this question, but no, there is no specific command to push. It is the same thing as previously, it's just get push. However, there are some commands that you'll need to use to actually switch branches and stuff like that, but we'll be going over that in like a minute. Okay, so yes, thank God. A majority of people said yellow. No, you do not go into another repository, you make a new branch. This is where your changes will go because you don't want to break things in the master branch. Ideally, this is where you want to develop your changes. So what are some of the best practices when it comes to branching? This is important in the industry environment and the projects in this class. So first things first, as I said before, you want to keep your master branch as clean as you can. This is the version of your code that will pass tests usually. It builds for sure, it compiles. You don't want any compiler errors in the master branch, and it is current. This is the version of the code that people can feel comfortable cloning and pulling down into their local repository without having to worry about, breaking all of their changes in their own version of the code. Make sure you name your branches well. Don't just say branch 1 or branch 2. You want to actually name what the branch is for. So, in the example that we had previously with the Android app, if we're creating a new feature like a settings page, name it like features/setting page. There's no like objectively correct way to name your branches. It is really dependent on the team that you're working on. But as long as it is descriptive of what the feature on the branch is or what the goal of the branch is, that's good enough. And then finally, review the code before you merge it into the master branch. So this is keeping the first point in mind. Before you merge things back in, you want to have usually someone else review your code to make sure that it's not malicious. You don't have anything accidentally, breaking or you're exposing certain things that you shouldn't, whatever it is. You can review the code, merge it into master, and this is your way of ensuring that the code is objectively fine. It is correct. So here are some commands for branching. So we have git branch, which will allow us to list the branches in our repository. And if we put a branch name next to it, we can make a new branch to work on. Git checkout is how we can actually navigate between the branches that we have. So you just put the branch name right after it. And so this is how we move that head pointer that we talked about previously around. It'll just basically, when you check out a branch, it'll update your working directory with the files that are stored in the branch that you're switching to. And I'll show you a little bit better what I mean by that once we're actually demoing these commands. So you can add the -b flag right before the branch name here to not only switch to that branch, but also create that branch. So this is your way of creating a new branch and switching to it, as opposed to git branch name, which just makes the new branch. And then if you're on the branch that you'd like to merge into, you can use git merge and the branch that you want to merge in to merge the two branches together. So let's make sure we demo that so you guys can make sure you understand what's going on. So let's say we have this shopping list. And let's say I want to add a new feature. Let's say the feature that I want to add is the money total. I want all, the total of how much this shopping list is going to cost me. So as you can see, I'm on the master branch. So before I develop this new feature, I want to branch off. We want to have this sort of feature-based branching that I'm talking about. So how do we add a new branch? Well, we do either get branch and then the name of the branch, or I prefer doing get checkout -b because it'll also switch me to the new branch that I'm making. So get checkout -b and the name of the new branch that we want. So we'll call it feature/money total. So now, as you can see, we've created a new branch and we've switched to it, and we can do get branch, which shows you a list of the branches that are in our local repository, and the star just basically says we are currently on this branch. So if you look at my VS Code here, you can see that it made a copy of the branch that I was branching off from. So this is the new branch that we're on. It copied over the file, the version of the code that we were working on previously. So some questions, someone says, does get branch list all branches no matter where you are? Yes, it does. If I do it from the master branch, it'll just have the star next to the master branch. So I can show you that if you want. I can switch branches by doing get checkout. And if I do get branch, you'll see that the star is now next to master rather than this. But I want to show you guys what we should be doing when we add a new feature. So I'll be working on the feature/money total branch. You can see I'm there currently. And so let's say I just add this new feature, money total. Let's say this will cost me about $300. So this is a trivial example, right? Ideally you'll be using this kind of feature-based branching in large-scale projects where you're adding like a new page to something or a new bug fix, whatever it is. So, but in this case we have to keep it simple. Technically, we haven't taught a programming language yet, so we're just using a trivial example, but you can imagine it on a much larger scale than this. So we've added our new feature. Let's go ahead and commit it. Add and commit. We'll say added money total feature. And so I can either just merge them locally or I can push it to the remote. I'm just going to go ahead and push it first just to kind of show you guys what happens when you push a brand new branch that you made locally. So this is what it tells us. It'll tell us basically the remote doesn't know that this branch exists. If I show you guys here on the remote repository, it only knows that there's currently a master branch. This is a list of all the branches that is on the remote. So what this message is telling us is that the remote doesn't know that we just made a new branch, so we'll have to set this upstream to the origin, which is GitHub, basically just adding this new branch. Another thing is, if Git tells you to run certain commands, most of the time you'll be fine if you run those commands. So I can just copy and paste this, and it'll be pushing the new branch with the changes that we have on it to the remote. So that's just kind of to show you what it's like to push a new branch to the remote. Someone asked, does it matter if the flags are before or after the arguments? Yes, it does. You want -b to come before the text involving your branch name. So here is our new branch on the remote. We didn't have to do this to show you guys what I'm about to show you next, which is merge, but I wanted to show you what happens when you add a new remote to the branch. Branch to the remote. So let's say I'm done working on this feature and now I want to merge it back into master. So this was that visual that I showed you guys here. So let's say my feature branch, this is where I was working on the money total. Now I want to merge it back in. So how do I do this? Well, we said we use git merge from the branch that you'd like to merge into, like so. So here I am. I'm going to switch my working directory to the master branch. So I'll do git checkout master. And so as you can see in my working directory, it has updated my files with the version that was on the master branch. And so if you remember, there was no money total feature. So now if I want to merge that feature in, I'm on the branch that I want to merge the changes into, the master branch. So I can just do git merge and then feature/money money total, just like so. And if I go ahead and show you the file again, we're still on the master branch, but now it has actually added in it has merged the new feature that I was talking to you guys about earlier, the money total. So these are some commands. Someone says git merge merges on your local machine. That is correct. I can go ahead and actually, if you'd like, send my changes back to the remote. And I can do git push. And so as you can see on the remote, now I have my new feature here. And so another thing that I want to show you guys is this extra command that isn't exclusively a branching command, but it is useful if we have a branch that instead of being created on the local repository is created on the remote repository. So this is git fetch. So essentially what git fetch does is it'll bring changes in from the remote, but it won't merge things together. So this is kind of what I was trying to tell you guys earlier with git pull. Git pull is a combination of actually doing git fetch, where it'll bring in the changes, but then also it'll run git merge on top of that. So it'll bring the changes in and then merge them together with what you have. Git fetch does not run the merge. It just brings the changes in. So I'll show you what I mean. Let's say it's especially useful for bringing in new branches that you want to bring in without actually having to, merge things in other files. So let's say I just add a new branch for demonstration. I'm not going to think too much about what the name of it is. Let's just say demonstration. So we've created a new branch on the remote. And let's say I list off the branches. Here you can see it's not there yet. So I can just run a git fetch. And let's say I just go ahead and do git checkout demonstration. You'll see that it brought that new branch in. That's all it did. It just brought in the changes without merging anything together. And now if I run git branch again, you'll see that now we have this new branch on our local repository called demonstration. So that is git fetch. And so as we said, git pull runs git fetch and git merge. We've already showed that. So an important part of the feature-based branching that we talked about. We want to be able to review the code before we merge it back in. This is especially important for our projects. Someone asked, can others work on the branch that you made? Yes, absolutely. If you have someone else that is working with you on this feature that you're working on, this new feature, yes, they can push to that branch just like you can push to that branch. So this is our new concept. How can we review the feature code back to master before we merge it back in? So this is this idea of pull requests. So I'm covering the slide a little bit here. Pull requests are basically saying that we are requesting to pull code into the code base. So alternatively, we are proposing a change. So let's say we've branched off from master and we've created this new feature called money total, or even the Android app, let's say we've added a settings page feature. You can create what is called a pull request on GitHub. This is a feature that GitHub provides, not Git by itself. And you can basically say, I propose a change to the master branch. I have this new feature, and I would like to propose this change to pull the code into the code base. So let me go ahead and show you exactly what I mean by this. So let's say we're on the master branch, and I want to create a new feature, and we'll call it feature/locations. And so I can go to my text editor here. Let's say my new feature is I want to add a list of all the locations that me and Rohan like to go shopping. I've never gone shopping with Rohan, but let's just go with it. So let's say we like to go to Walmart and Aldi, the classic, right? So I can commit my changes to this branch. So we'll say added locations list feature. And so now let's say I do git push, because we actually do have to do git push in this case, because this is a feature on GitHub. So we'll send our change off to the remote. Again, GitHub does not know of this new branch that we made locally, so we need to set this upstream. Again, if Git tells you to run a command, most of the time you'll be fine. So this is how we send that new remote off, new branch off to the remote. And so on the remote, you can see it says you have pushed this new branch not too long ago. Do you want to create a pull request? The pull request, we said, is how we propose a change to our code base. So here we'll go ahead and continue. We'll say sure. And if you look here, it's saying that we're able to automatically merge these two branches together. Great, because we don't have conflicting changes. We don't have any changes in the same lines or same areas. And we're merging it back into the master branch. So we're basically saying to everyone working on this repository, I am proposing a change to the master branch in which I have added a locations list feature. So I can go ahead and create this pull request. I can add a comment. And for your projects and your homework, you're going to have to assign a reviewer so someone else can actually review your code. So in this case, your project manager, just to make sure the code is fine. So you create the pull request. And so now, if I go ahead and just show you on the pull request tab, these are all of the this is a list of all the pull requests that we have, all of the proposals to make a change in our code base. So in this case, this is the one that I made. When you click on the pull request, you can review the code. You can see all the files that were changed. So in this case, we can see that the only thing that I've done is made an edit to shoppinglist.txt, and I added this locations list. Ideally, I would have someone review this code to make sure we have some extra eyes on it, but I'm the only one here, so I can't really do that. I'm just going to say that I own this repository, I'm the only one working on it, and it looks good to me. And so we can just merge it in right now. We can just merge the pull request and confirm the merge. And so when I go to our master branch here on the remote, we can see that our new feature is added, locations list. This is how we want you guys to do things. Someone said, is there a way to do this on the CLI? No, there isn't. Pull requests is a feature on GitHub, not Git locally. Okay, so I already demoed that, and so this introduces us to our second workflow. This is how we will be doing things in the projects in this course, and likely how you will be doing things in your internships if your team works in this fashion. For every new feature that you create, you make a new branch. You make changes as you please, as like a little, playground area. You're not worried about adding malicious code because you're, safe on your own branch. You submit a pull request once you're done. You get your code reviewed by the team, by your project manager, and then you merge it back into the master branch. This is our second workflow in this course. And so there's going to be a couple more simple steps that we're going to talk about to amend this workflow, but for the most part, this is all you have to know for now. Project kickoff Thursday, by the way, for all of you who are wondering. So I hope that made sense. Let's see if we have any questions. People are asking if you can do this in the CLI. No, it's a feature just to GitHub. Why was there not a pull request when we pushed the previous branch? I was just showing you how to merge it locally, but in this course, you will be using pull requests to merge branches together. I was just showing you the use of the merge command, but if you want to merge branches together in this course, we expect you to use pull requests because that allows you to actually add reviewers and make sure that you don't have malicious code added to your master branch. Can I go over how to do a pull request again? Sorry, we're low on time. Just watch the recording later once it's up. So, some more useful commands. We have git status, git stash, git log. So git status, essentially what it does is it'll compare the working head, the one commit that we're on, with the latest commit, the commit that was most recent, and display what has changed. So just to quickly demo it, if I run git status, I showed this off a little bit last lecture, but it basically shows the status of our repository. So here, everything is up to date. Let's say I add a change here. So let's say, testing 1, 2, 3. And I do git status. It'll basically say you have some modifications that you haven't added or committed. So that's just the status of our repository. Git stash will save changes that you don't want to commit immediately. So basically, if you have some changes since the last commit that you made, git stash allows you to kind of just stash them away somewhere in memory. And if you want to use those changes, you can. If you don't, that's fine. You don't have to. So let's say since the last commit, we had just everything up here. So this is the only change since the last commit. Let's say, I'm not sure if I want it or not. I just want to save it away. I can do git stash. And so you'll see that now that it's saved that away somewhere, I don't need to use it if I want to, but if I want to use it, I can do git stash apply. And so basically it'll just give me my save back. That's all git stash does. Sometimes git will tell you to run git stash in some points, but it's useful to know what it does so you're not afraid when it says, hey, you might want to stash your changes before you merge or something like that. Git log. Someone says, can you stash more than one thing? Yes, it just basically all of the changes that you had since your last commit, git stash will store those changes away. In this case, it was just one line because I only added one line. But if I had a million lines, it would stash away those a million lines. Git log is how we can view information about previous commits, and you can use the -- one line flag for readability. So this is important for what I'm going to show you next. So git log by itself will give us a lot of information about who made commits, about what the commit, what message was, stuff like that. I prefer personally to use it on one line with this flag. It's a lot shorter and it's a bit better for readability. So this is our commit history. The one on top is our current commit, and everything under it is all the ones that came before it. So let's go ahead and we'll have our last few commands here. These are very important because one of the first few things that I told you in our first Git lecture is that Git allows you to also go back to changes that you've made if you want to roll back. So this right here is how you can do it. There are essentially 2 to 3 different ways you can go backwards. You can do git revert and git reset. So git revert is a bit safer than git reset. And the reason why is because the way that you roll back is it'll reset to a previous state by reverting new commits, but keeping the original commits, and just basically making a new commit with the commit you're trying to go back to. So that was a mouthful, but here's a visual of what I just said. So let's say you are currently on commit 3, and you want to go back to commit 1. Git revert will just basically create a new commit with a copy of version 1, of commit 1, and tack it on at the end. It's not going to delete any commits. It's going to go backwards by just creating a new commit with the version of the commit that you're trying to go back to. So let me go ahead and demo this in case I am making no sense. So I am currently on this top commit where we're adding a locations feature. We have already committed that. And let's say I want to go back to when I added the pen to the shopping list, for example. If I do git, we said git revert, and then the hash code of the commit that I'm trying to go backwards to, I can just put that ID of the commit. This is basically the commit's ID, its unique ID. And I want to revert back to this shopping list. If I do git revert, it'll just basically, so let me actually listen to git for a second. So it's just basically saying commit your changes or stash them before you merge. So like I said, sometimes you have to listen to git. So if I do git revert, and then the commit that I'm trying to go back to, and we do, hold on. Okay, let me commit my changes. Save before merge. Okay. Let's just say I push it just for the sake of clearing up something that I don't feel like explaining right now. Okay, so one last time. Let's say I want to revert back to a previous commit. Then I can just put the ID of that commit, git revert. Could not revert. Oh, it's telling me that I have some conflicts. Okay. Okay, let's revert to a different commit. Let's revert to this one. Let's say git revert here. Okay, I have unmerged files. Git is being very difficult right now when I'm trying to show something. Okay, let's try this again. Git log, one line, git revert. Let's say we're going here. Revert failed because no, okay, sure git, here. Oh my god. Just trying to show something, git. Git push. Okay. Here we go, guys. It's gonna work this time. Okay, let's try it reverting back to initial shopping list. Okay, listen, we will be covering that in an instructional video that I will be posting right after this lecture. Let me basically explain what should be happening. So right now I'm getting merge conflicts basically, and I'm running out of time. That I don't feel like fixing them right now. So I will be showing you essentially what's going on right after the lecture. But essentially, if I do git revert to, let's say, this commit, it's going to add that commit right on top. It's a commit that we're going back to. It's going to add that new commit right on top, and we're not going to delete any commits. Git reset, on the other hand, will basically reset the state of the branch by dropping all the commits that came after it. So if I want to go back to 1 when I'm at commit 3, it's going to drop everything that came back to it. So I'm going to actually try that now. If I do git reset to, let's say, the initial shopping list, okay, it worked. And if I do git log one line, you'll see that it actually dropped everything after initial commit, initial shopping list. All of these changes were deleted. Git reset or git revert, on the other hand, what it's supposed to do is instead of deleting those commits that came after, it's supposed to add it to the top. I wasn't able to show you that because of some unfortunate, unforeseen circumstances. However, I hope that makes sense. Now, an important thing to note is the difference between git reset and git reset -- hard. -- hard flag basically does exactly what git reset does. However, it does stage changes. And so what that means is, oh wow, you can see all the merge conflicts that happened in this file while I was trying to reset. Basically, Git wants me to fix these. But so with git reset without the hard flag, it'll basically have unstaged changes, meaning the changes are still here if I want to save them. However, git reset -- hard, let's say I go all the way back to the initial commit right here, then you'll see that it actually deletes, it actually goes back and it doesn't save the changes locally. So here, if you look up here, the file is deleted because in that initial commit, the file didn't exist. That was before I even added the file. So you'll see that now when I do git log -- one line, all of the commits are deleted after it, and in this case, since it doesn't stage the changes, it actually replaces everything in our working directory, and we can never get those changes back. That is why reset is more dangerous than revert. You should really just use revert. There's no reason not to, basically. It'll save your previous commits rather than delete them, and it'll append the commit that you're trying to go to right at the top. I hope that makes sense, even though I wasn't able to show you revert because of merge conflicts that I was trying to get past without wasting time, but instead I wasted even more time. So that is all of the content for today. This is not everything there is to get, but there is quite a bit that we've covered today. This is basically everything you'll need to use for your projects in this course. And essentially, a majority of all the commands you'll use if you go on and get a job in industry or an internship, whatever it is, or any projects that you want to work with your friends. But Git takes a bit of time to get used to. It'll take some Googling. It'll take some, it'll take some practice. So Git is something that is not something you might get right away. So I've linked this tutorial down here. It goes very in depth into the concepts that we might have taught or we might have not taught if you want to see them. But that is basically the lecture for today. If you guys have any questions about anything, feel free to drop them in the chat. I hope the concepts that we went over today made sense, with the exception of that little slip up with revert or reset. But I hope it makes sense. I hope we're good. We will have part 2 of this homework is already out in your GitHub classrooms, and we will be releasing some questions on Prairie Learn that will help you get a little bit more practice with some of the commands. But if you guys have any questions, let me know. I'm here. I'll be staying here for a little bit. If you don't have any questions, you are free to go. You guys are good for today.